Welcome to Spaceverse, your portal to cosmic adventures. Imagine peering back into time farther than we've ever seen before and finding something so massive, so complete, it defies everything we thought we knew about the early universe. That's exactly what astronomers have discovered using the James Webb Space Telescope, a massive spiral galaxy born just 2 billion years after the Big Bang, now nicknamed the Big Wheel. Located about 11.7 billion light-years from Earth, this galaxy is one of the most remarkable structures ever observed from such a distant and ancient time. It's as large as the Milky Way, spanning roughly 100,000 light-years, and yet it formed at a time when most galaxies were still chaotic, irregular clumps of stars just starting to take shape. Big Wheel isn't just big, it's stunningly organized. Using data from the James Webb Space Telescope's Near-Infrared Spectrograph, or NIRSPEC, astronomers determined that it rotates with a well-formed, stable disk structure. That kind of organized motion is typical of mature galaxies in the present-day universe, not something you'd expect from one this old. The rotation curve of Big Wheel, that is, the way its stars and gas move at different distances from the center, matches those of well-developed spiral galaxies. Even more incredible, its maximum rotational velocity clocks in at several hundred miles per second. That's in line with the largest, most stable galaxies we've ever seen. What's more, it adheres to something called the Tully-Fisher relation, a fundamental correlation in astrophysics that links the brightness and rotation speed of galaxies. For Big Wheel to fit that relationship so early in cosmic history suggests it had already reached a state of equilibrium, an astronomical term for when a galaxy's internal forces are balanced. That's extraordinary for a galaxy that existed less than 2 billion years after the Big Bang. So how is any of this possible? To answer that, we have to look at where Big Wheel lives. This galaxy wasn't alone in some quiet corner of the universe. It formed in an incredibly crowded region. Astronomers estimate that the number of galaxies in this particular area is more than 10 times higher than the cosmic average. And in such dense environments, galaxy formation might follow different rules. In these bustling regions of the universe, gas flows more freely. There's more raw material to feed growing galaxies. There are more collisions and more mergers. One of the study's co-authors, Sebastiano Cantalupo, suggests that Big Wheel may have grown so quickly because it was able to tap into these rich cosmic resources. Gas from surrounding space flowed into it in a smooth, organized fashion, bringing angular momentum, essentially spin, which helped form its disk. The galaxy's enormous size and rapid development may also have been accelerated by frequent mergers with other gas-rich galaxies. Each collision would have added more stars, more gas, and more momentum. Instead of being torn apart or thrown into chaos, Big Wheel somehow managed to stay intact, growing, spinning, and organizing itself into a spiral structure. This discovery suggests that some galaxies in the early universe may have bypassed the usual slow and messy process of star formation. Instead of taking billions of years to settle into their final shapes, they may have fast-tracked their evolution in dense, gas-rich environments. In other words, cosmic structure may not always require cosmic patience. For astronomers, this is a game-changer. The discovery of Big Wheel throws a wrench into the standard models of galaxy formation. Most simulations predict that early galaxies should be small, irregular, and turbulent. But Big Wheel shows that large, mature galaxies were not only possible in the early universe, they already existed. If this is more than just a one-off event, it means there could be many more galaxies like Big Wheel waiting to be discovered. And if that's the case, the way we understand the early universe and how galaxies like our Milky Way came to be might need to be rewritten. Thanks to the unprecedented power of the James Webb Space Telescope, astronomers can now peer deeper into space and further back in time than ever before. They're not just seeing points of light, they're seeing detailed structures, motion, and composition. For the first time, we can study the architecture of galaxies in the early universe with the same precision we apply to nearby ones. And that means more surprises are almost guaranteed. The discovery of Big Wheel suggest that galaxy evolution is more flexible, more dynamic, and perhaps more chaotic than previously believed. It also shows us that the conditions in certain regions of the universe could give rise to extraordinary growth, galaxies that defy the norm and mature faster than anyone thought possible. This has implications not just for galaxy formation, but for the broader story of cosmic evolution. It may help explain the diversity we see in galaxies today. Some may have followed the slow, steady path. Others, like Big Wheel, took a shortcut. As astronomers continue to study galaxies at different distances, and therefore different times in cosmic history, they're beginning to see that the early universe may have been more structured, more organized, and perhaps more familiar than they imagined. Of course, that raises even more questions. Why was Big Wheel able to grow so large, so fast, while others didn't? Were there special conditions present in that part of the universe? Or is Big Wheel simply an outlier, a rare exception that doesn't represent the norm? These are the mysteries astronomers are eager to explore. And with tools like the James Webb Space Telescope at their disposal, we're entering a golden age of discovery. What makes Big Wheel especially compelling is that it's not just a scientific curiosity, it's a reminder of how much we still don't know. Every new discovery in space has the power to reshape what we thought was settled science. It challenges our assumptions, forces us to ask new questions, and deepens our appreciation for the vast complexity of the cosmos. The story of Big Wheel also highlights the importance of cosmic environment. Just like cities on Earth can foster rapid growth through trade, connectivity, and density, galaxies in busy regions of the universe seem to evolve faster. The more crowded the neighborhood, the faster the galaxy may grow. And while Big Wheel might seem distant, both in time and space, it helps us understand the story of our own galaxy. How did the Milky Way come to be? What was its path through time? Did it evolve slowly, or did it also have moments of explosive growth? These are the questions astronomers are now better equipped to answer. Big Wheel is more than just a giant spiral in the sky. It's a symbol of cosmic possibility. It's proof that the universe can still surprise us, even when we think we've got the story figured out. It challenges the idea that the early universe was chaotic and primitive. It suggests that under the right conditions, complexity and order can emerge much earlier than expected. And it reminds us that the cosmos is not just a place of vast emptiness, but one of endless potential. As scientists continue to study this remarkable galaxy, they'll be looking for clues about its origins, its environment, and its future. Was Big Wheel a one-of-a-kind early bloomer or part of a hidden population of early spirals? Only time and more data will tell. What we do know is this: the discovery of Big Wheel marks a turning point. It shows us that the universe still has secrets to reveal. It teaches us that we need to keep questioning, keep observing, and keep wondering. And most importantly, it shows that the story of the cosmos is far from finished. Thanks for watching. If you enjoy exploring the mysteries of space and the latest discoveries in astronomy, be sure to subscribe to Spaceverse. Hit the bell icon so you never miss a journey into the unknown. Until next time, stay curious and keep looking up.